Good morning! Today we're going to talk about fundamental frequency and resonance. So in yesterday's lesson you learned about what sound is and how it works, and that it's a mechanical wave that travels through a medium. And so that medium can change and the wave can change, and that'll change the pitch or the sound that you hear. And that is the frequency of the wave. So every single thing has something called a natural or fundamental frequency, and that's the sound that it makes whenever you strike it. So I have several different tuning forks here. This one has a frequency of 880 Hertz. And every time I hit it, it makes that noise. Okay, it doesn't matter how I strike it. I'm using this so it doesn't damage my table. But it's always going to make that sound. This one has a frequency of 1000 Hertz. And that has a higher frequency and therefore a higher pitch. Every single thing does this. I have this wood flute here, and by changing the position, I can change the sound that it makes. Or you can either how's that?
Good.
Okay, good. So everything has that. And as you change the object, when you make it smaller, you make the frequency higher because you make the wavelength of the wave smaller. For example, if I play this meter stick, it makes a sound when it vibrates. But if I make it shorter, if I make it so it doesn't extend as long over the table, the sound goes up. Okay, very well. So that's fundamental frequency. However, something really interesting happens. Did you like that, Hannah? Something really interesting happens. I know, how crazy is that? So something really interesting happens when you make an object vibrate at its fundamental frequency. Because when you make it vibrate at its fundamental frequency, you get it to vibrate at a much higher volume or amplitude than it would normally. So the size of the wave, not how close together or far apart the wave is, but how large the wave is determines the volume or the sound, the amplitude that the wave has. So I have a thing called an Ames tube, and it's basically just a hollow tuning fork. You can see right down through the middle, but it is a tuning fork itself. And when I play it, it just makes a louder sound because of there being the hole in the middle there. But it's 880 Hertz. But something interesting happens when you make it vibrate at that frequency. So here's 880 Hertz. It's the same sound as this. This one's just a little bit louder because it's larger. What, ma'am?
Where are the micro machines?
I don't know where they are. Are they by the door?
Do you need any help, Daddy?
No, but if you want to stand here, you can listen to Daddy's video.
Because you might need because you're going to need help later.
Maybe. So if I force it to vibrate at the frequency, then something interesting happens. No, you're just watching. Ready? So I'm going to make this vibrate by playing this and bringing it near it. They're the same frequency. So when I do that, this happens. What do you girls think of that? So what happens when I do it? Not higher, louder, right? The reason for that is called resonance. It's when you make something vibrate at its natural frequency. A great example of this is if you've ever been singing in the shower and all of a sudden some note that you sing sounds so much louder than it would normally, that's resonance. And it's a phenomenon that happens when you play things at their fundamental frequency. But here's something else that's kind of interesting. What if I play not the fundamental frequency? This one's 1000 Hertz. You probably can't read that, but it's 1000 Hertz. It's not the same frequency as this. When I do it on this one, nothing happens. It's the same sound, and that's because this doesn't want to vibrate at 1,000 hertz. It wants to vibrate at 880. So when I play 1,000, there's no discernible difference. And that's because resonance only occurs at the fundamental frequency. So the next thing we're going to talk about is beats. Beats are what happen when you don't play exactly the fundamental frequency, but you play really darn close to it. So the next video you'll watch will be an example of that. I'm also going to have a bonus video that's a different example of resonance. It's a resonance of a bridge. It's something that you wouldn't think of as resonating, but everything has a fundamental frequency. No matter what. So watch the next two videos. You can watch the bonus video and watch the next video on beats, and then we'll be back with you with one more video talking about how sound waves look and interact. Goodbye!